Hello everyone, welcome to Maths IEC. Here's another common A-level physics exam question on mechanics. Please pause the video and try this question. When you want to check the answer, press play. A student of mass 65 kilograms, let's mark the mass of the student, 65 kilograms, stands on a set of bathroom scales inside a lift. The lift accelerates upwards at 2. So the acceleration in the upward direction is 2. Okay. Calculate the reading on the scales. Now, we need to think about the forces acting on this student at this point. So, obviously, there is weight. So, the weight here is mg, which is 65 times 9.81. If you think about this student, there is only one contact that this student makes. Now, we'll assume both of the legs as one. I mean, in reality, there are two reaction forces starting from one from each leg that are approximately equal from a stance like this. But let's just mark one like you normally do. Normal reaction force. Let's call it capital R. Now, that's it. Forces are just that. Now, under these conditions, this person is accelerating upwards. We are going to write F equals ma in the upward direction. F is equal to ma. The upward force is R minus the downward force is mg, which is 65 times 9.81, is equal to ma. M is 65 times A is 2. So I can easily work out my reaction force. Now remember, the reaction force on the scale is the reading on the scales. Why is that? Now think about it. Here's the scale. The student pushes the scales down and the scales pushes the student up. These two form a Newton's third law force pair. So they are equal and opposite, equal in magnitude and opposite in direction. So the answer is 768 newtons. So the reaction force is 768, but really if you are considering the fact that the bathroom scales are usually given in kilograms, so you can even get the actual reading on it by dividing 768 by 9.81, which gives you about 78 kilograms. So that's the thing. So this person is only actually 65 kilograms. It shows a reading higher than this person's actual mass. So either way should be fine for part A. Explain why the scale reading is different from the student's weight during the acceleration. Now, if you think about the acceleration phase, what happens is R minus mg is equal to ma. Now, obviously, R needs to be bigger than mg so that it can provide a force for the student to accelerate. So usually a question like this will probably be about worth 2 marks. So you can say the lift accelerates upwards. So the scale must exert a greater upward force to accelerate the person according to Newton's second law. There must be a resultant force in the direction of the acceleration. That's the first point. This increases the normal contact force R, making the reading larger than where the lift is stationary.